Okay, so for Unit 8, Day 3, we're going to be looking at volume of solids of revolution. So just a recap from last week, we were looking at area under the curve. So if this is our function and we wanted area under the curve, to find area under the curve, you would take the integral from a to b of that function, and that would give you the area under that curve. So what we're going to do is we're going to take that function that we have here and we are going to revolve it around some axis. So many times the axis is going to be the x-axis, but it doesn't always have to be. So if you can imagine taking this two-dimensional shape and spinning this x-axis, then you would get this volume, this solid that we see in the second picture. So if that's the case, our goal is to figure out what the volume of that solid is. So let's back up for a second. If we remember, in this first picture, when we were first trying to find the area, we would take these rectangles and we would add them up from left to right. And then what we would do is we would take that rectangle and make that value small, that width smaller and smaller and smaller, which means that would approximate the area under the curve. So what we're going to do is when we rotate this, you can see that this rectangle now becomes this disk, this three-dimensional disk with a very small height. And if you remember, the area of a disk, that's a cylinder actually, the volume of that would be pi r squared times height, where this height becomes this dx. And if you look at that in this third picture, if we do that with all the entire volume, we have all of these cylinders, and then if we add those up, that would approximate the volume. And if we took that height of each of those cylinders and made it smaller and smaller and smaller, that would make our volume closer and closer and closer to what the actual volume of the solid would be. So just like in the area where we take the integral from a to b of that function, to find the volume, what we're going to do is we're going to take the integral from a to b of this volume function. So the volume is going to be the integral from a to b of pi times r, and in this case r is going to be that function value squared, and then the height becomes that dx. So that's where we're going to get that from. I'm going to rewrite this, and I'm going to take out f of x, and I'm going to put a big capital R there, because the function value is not always going to be the radius, and you're going to see that in a few different examples. Sometimes it is, sometimes it's not. But in any case, the formula is the same. Pi r squared h is the same for the volume of just a normal cylinder. It's going to be the integral part just adds up all of those cylinders. All right, so let's take a look at an example. So an example, it says, find the volume of the solid of revolution generated by revolving the region bounded by those functions about the x-axis. So our first step is going to be, it is not going to be to write an integral. It is going to be to draw that graph and see what everything looks like. So the first one is the square root function. Y equals 0 is the x-axis, and x equals 4 is just that line there. So you can see this is our function, and they say to revolve that around the x-axis. So if you can imagine, I'll draw it smaller over here. When we take that and we revolve it, we end up with this bell-shaped curve. And that's going to be kind of what we're looking to find the volume of. So back up here, we need to figure out this radius. And this radius is just that function value. It is that function value square root of x. No matter where we're at on that, it is the square root of x. All right, so to find the volume, we are going to say pi times the integral, and we are going from 0 to 4. So pi radius squared dx. So again, pi r squared. Again, all of these are all going to be circles. When they rotate, you can see that there's a circle there, there's a circle there, there's a circle all the way along. And if we add up all those circles, we end up with the volume. All right, so let's go through this again, step by step. Well, if I simplify this, the square root of x squared is just x. And then keep on going. The integral of x is x squared over 2. And we're going to evaluate that from 0 to 4. So let's go ahead and plug in a 4. When I plug in a 4, I get 16 pi over 2, or 8 pi, minus, and when I plug in a 0, I get 0 pi. So my answer is 8 pi, and then since this is volume, we're going to be looking at cubic units. So that is how you would do that problem. The hardest part of these problems is sometimes going to be figuring out what this radius is going to be. Sometimes it's easy as just taking the function, sometimes it's a little bit more involved. All right, in example 2, we have different functions this time, so let's again draw our graph. We've got sine of x, we got y equals 0, we got x equals 0, and we got x equals pi. So this is going to be the shape that we are revolving. We're going from 0 to pi. Around the x-axis again, so again a little bit smaller. If we revolve this and we revolve it around this axis, we end up with this football-shaped looking object. All right, so in this case, the again is going to be the radius is going to be just that function value, just the sine function. So this is an easy example. Again, pi from 0 to pi r squared dx. Now, this is an example of a problem where when we do the integral, we do not have an integral at this point for sine squared of x. So what you need to do is, this is an example we're going to need to use the calculator to solve this for you. So if you have a calculator, you can use, if you press math and then go to the bottom of that, there's an FN integral sign button, FN. Let me rewrite that. This is on the TI 84s. It's very similar on the TI Inspires if you have one of those, or you may just have to use something like Desmos. Desmos has integrals built in as well. So I'm going to go ahead and plug that in. Integral from 0 to pi of sine x squared dx, and that's going to give me an answer of approximately 4.935, again, cubic units. So anytime you have a trig function, you're going to want to use the calculator to solve those. Everything else you're going to want to try to do without the calculator.